Let's look at convertible kinetic energy. 20. Is the convertible kinetic energy of a system of objects the same in all inertial reference frames? The convertible kinetic energy, is it the same in all inertial reference frames? So let's just, I know we've done this a few times now in this section of videos, but remember that the kinetic energy of a system in a reference frame, let's call it E, this is the Earth reference frame, but it can be any reference frame, is equal to two components, the non-convertible and the convertible. The non-convertible kinetic energy is based on the velocity of the center of mass. Okay? Remember, this velocity of the center of mass is the same as your zero momentum reference frame, which is just the momentum of the system measured in the Earth reference frame divided by the total inertia of the system. Okay? So if I change my reference frame, then this velocity changes, right? If I change my reference frame, the velocity of the center of mass will change, which means that the non-convertible kinetic energy changes in different inertial reference frames. But the convertible kinetic energy is not measured in reference to this reference frame, but it is the same as saying it is the energy in reference to the zero momentum reference frame. Okay? So you can go check out equation 631. Okay? Let me just get something here. From the textbook, on page, let me just get it quickly for you. Page 160. This term is the kinetic energy of the system measured in the zero momentum reference frame. Okay? So this kinetic energy, this is the convertible kinetic energy. It does not change based on different inertial reference frames because it is in reference to the zero momentum reference frame. Okay? Whereas this kinetic energy, which is non-convertible, does change in different reference frames, inertial reference frames. So I know it's kind of counterintuitive. It says that this is non-convertible, okay, and this is convertible, but yet if you change reference frames, this doesn't change, and this does change if you change your inertial reference frames. Okay? So I know that's confusing. This is not so easy to understand the first time. But just remember that, say now you have an object that's moving with a certain velocity, okay? That object has a certain kinetic energy, half mv squared. And remember, this velocity is measured according to some reference frame, right? But if I say I'm moving it in another inertial reference frame, B, then am I right to say that that velocity will change? This velocity in this reference frame will be different, which means that I will have a velocity in the E reference frame, but then if I look at it in this reference frame, it will be different. It'll have a different velocity, so that means that my velocity of my center of mass has changed. Okay? So I hope that makes sense there. In a different reference frame, this velocity will change, which means my non-convertible kinetic energy will be different in a different reference frame. But my convertible kinetic energy, in a sense, is independent of the reference frame you're looking at, and it is dependent on the zero momentum reference frame. Okay, so if you've got two objects, they both have certain velocities. Okay, can you see that you've got a velocity of the center of mass, and then you've got velocities of these objects, and actually in this case they're all measured in reference to a specific reference frame. But if we calculate these velocities in reference to the zero momentum reference frame, so velocity 1 z, velocity 2 z, right? They're not in reference to this guy anymore, they're in reference to the zero momentum reference frame. Then we can also calculate their kinetic energies, which is this, right? Their kinetic energies, and it is independent of these of say an E reference frame or a B reference frame, but it is based on the zero momentum reference frame. Okay, so these do not change because they don't change based on changing reference frames, whereas this guy does change. Okay, I hope you understand that. Okay, well, I've tried my best to explain that. Let's move to 21. Which part of a system's kinetic energy changes when an observer switches from one inertial reference frame to another? We just did that. The convertible or the non-convertible? It is the non-convertible part. I know it's counterintuitive. Non-convertible, you think, oh, that doesn't change. No, the non-convertible part is this part. Okay? And it's based on this velocity of the center of mass. Okay, which is different in different reference frames. So this non-convertible part does change in different reference frames. Okay? Can all the initial kinetic energy of two colliding objects be converted to internal energy? Can all the initial kinetic energy be converted? Okay, can all of the kinetic energy be converted? Well, only if what? Only if what? Only if the velocity of the center of mass is 0. Does that make sense? So all of your system kinetic energy becomes convertible if the velocity of the center of mass is 0. So we've done this multiple times, but go look at example 6.8. Look at these two examples. You've got one box or whatever it is, or I don't even know what it is, doesn't matter. Object moving with a certain velocity, the other one with a 0 velocity. So in this case, you can see that it's got a center of mass that is moving, right? It's the velocity of the center of mass is non-zero. So if the velocity of the center of mass is non-zero, then you're going to have a half mv center of mass squared. You're going to have a non-convertible kinetic energy, and then you'll also have a convertible component. What about this guy? You've got this object moving this direction at 6.7, this moving in that direction at 6.7. They have the same inertias. So what is going to happen to, what is the velocity of the center of mass in this case? It is 0. It is 0, which is the same as saying that the momentum of the system is 0. The system. The momentum of the individual object is not 0, but the momentum of the system, meaning the momentum related to the center of mass is 0. The velocity of the center of mass is 0. So this guy is 0. So all of your kinetic energy of your system is convertible. Okay, I hope this is making sense. All right, 23. So the answer is yes, only in the case where your momentum is 0 or your velocity of your center of mass is 0. Okay? So the point is here now, it's possible to change your reference frame so that your velocity of your center of mass is 0. And then in that reference frame, all the kinetic energy is convertible. Okay. What is the maximum amount of kinetic energy that can be converted to internal energy in a collision? What is the maximum amount? Let me just go quickly to the solutions to get the exact equation here. Okay, so it is this. The maximum amount is half mu v12 squared. Okay, that's the maximum amount of convertible kinetic energy. Remember, this mu here is m1 m2 over m1 plus m2. It's called your reduced inertia, and this is simply your v2 minus v1. Your v2, it's your initial relative velocity. That's the maximum there. And in which type of collision is this maximum conversion possible? It has to be a totally inelastic collision. Okay? Alright. Okay, I think we can stop there and we'll try to finish off in the next video.